Hello guys, welcome back to my channel, Memo African Motives. Still working on engineering science N3. So in this platform we have a question that we are going to focus on from the question paper of April 2020 that we had, which we are going to actually focus on forces. So that's a question which was actually a request, so that is why we had made this class so that we can see how we're supposed to answer the question, which was on forces from the question paper of April 2020. So actually guys, if you're new to this channel, you can consider subscribing so that you become part of the family Memo African Motives, so that anytime I upload a new video, you'll be part of the classes that we shall be having. So in this case, we are very sorry for that, using the TVET papers, but we just want to focus on this part, guys, which is on forces, which is from this question paper. So we are given there to define parallelogram of forces, and you've got 2 marks for that. This one, guys, is just a definition, normal definition. So as you know, we always bring a definition that you can actually use. So this one is not going to be clear, all of it, but we are given that parallelogram of forces, that is, if 2 pulling forces acting at a point are represented in magnitude and direction by 2 adjacent sides of a parallelogram, the resultant of the 2 forces is represented in magnitude and direction by the diagonal of the completed parallelogram drawn from the point where the forces act. So that is actually what you are referring to. Remember, guys, this concept here that I just want to explain so that you understand what's happening, how you apply this concept. You'll be given maybe 2 forces like this, which are acting at a certain point, and you'll be given a certain angle, which is maybe 60 degrees, like that. So you formulate a parallelogram like this. By joining, you're going to have a parallelogram. So the resultant that we're talking about is the one that is taken from where these forces are acting at a point to the other point, like this. So that is where we are going to have the resultant. So that is actually when you're having parallelogram of forces, and how you find the resultant is not important for the meantime. What we just needed is to understand that definition that we are given there. The another question is to determine the magnitude of the unknown forces shown in the system of forces in Fig 3. This is our Fig 3, and we are given a number of forces there, which is the part that we just need to actually consider and see how we're supposed to collect these 6 marks that we're given there. So the first thing, guys, like I always say, that you need at least to redraw your diagram in a better way that you can actually understand. Okay, so because we know that forces should be taken from the point, not to be pointing at a point like what is this force is doing. This M is pointing the same way this 8 Newton, this one is pointing. Take note, this arrow here is at this, it's supposed to be at this point here at the center, not here where it is supposed to be here at the center. At this point, that is where this arrow is supposed to be, this one. Okay, so I'm just going to redraw that and see what it was supposed to look like. So if you are to see from this one, it's actually a horizontal line and a vertical line. What proof gives us that? This is 30, this is 30, this is 30. So if we add 30 plus 30 plus 30, we are going to obtain 90 degrees. And 90 degrees is only a condition where we meet 2 lines as a vertical and a horizontal. That's the only condition that you can give us a 90 degrees. So we can be sure that this is a horizontal line and this is also a vertical line. So these are the 2 major lines that you're going to start with. Okay, so remember, a force should be from the point, not to the point like it is, not to face the point like this. It must be from the point facing like this or like this. That is what a force is supposed to, from the point, but this one is facing the point. So what do? I just continue with this force straight, which means it's going to be on top. So we are going to have our diagram like this, guys. Let's say this is our center. here. So we are going to have this force now, which is now on top like this, and where it came from, you just indicate dotted lines where this force was taken. Okay, so this is now our M, which is now on top, this M here. We are now having our M at this point. All right, but remember, we agreed here that this M and 80, this one, they are giving us a 90 degrees, which means we're talking about a vertical line and a horizontal line. So it's the same thing. This 80 is going to be taken from the horizontal this side to the left side. So you're going to have it to the left side like this. So where it came from, you just indicate with what? Dotted lines like this. Then it continues with its direction, because it's supposed to be from the point, not to the point, but from the point. All right, so that's what you can actually do. There's another way that you can actually do this of writing these forces with negatives, but most of you forget. So it's best for you to at least redraw this diagram. Maybe it's gonna be best. Okay, so this one is from the horizontal, which is this horizontal. We've got this 70 here with 45 degrees. So it's just like this one. That's 70 newtons and 35 degrees like this. So this one is from the horizontal, so it has no effect. Then we have got L is from the point, so it has no effect with 30 degrees. So we're just going to take our L direct like that. From this point, this is our L here with an angle of 30 degrees to this direction. All right, so take note, this is 35 degrees and 50 newtons here with an angle of from this point here, because you're taking from this line. So as you can see, from this line up to this point here, this whole angle is 30 plus 30, which is 60. So you're going to take this with 60 degrees now. So it's going to be like this. All right, so this is your 50 newtons here. All right, like this with an angle of 4. So from the horizontal line here, we are going to take an angle of 60 degrees. So this one is going to be 60 degrees from this one. So take note, your angles should always be taken from the horizontal line, from to the line of force, like this one, L, the line of force, and angle of 30 degrees, 70 newtons with the angle of 35 degrees. So always, that is the concept. But we agreed this is 45, not 35. This is what, 45 degrees here from the diagram. Take note here, this is 45. Okay, so and this is going to be 45 because remember, this is just a straight vertical. So but there's no need for us to represent it. Even this one, there's no need for us to represent it. So these are the all forces. So this 30 degrees is the one that gave us a consideration to agree that this is 90 degrees. So that is going to be like, so it's just a condition that we did. This is now a continuation, the same thing, this one continue to do. That is what we just did. Okay, so once you know this concept, it's now easier for us to calculate the value of L and the value of what, of M. All right, so how are we going to do this? Okay, I'm going to start with this concept. We know that whenever you are working with forces, the forces that you have to the right should be equal to the forces that you have to the left. So F right is equal to F left. We can formulate an equation from that. Which forces are we talking about when we are talking about forces to the right or to the left? These are forces which are on a horizontal line like this. That is your right and that is your left. So which means you're talking about a horizontal line, and anything that lies on horizontal line has to do with cos. Because remember, from your angles, guys, if you are given something like this, this is theta, this is adjacent cos. So anything that is in the horizontal has to do with cos. So this force is in the horizontal, so which means you're having something like this here to form a triangle. But this right angle triangle like this, if you are to cross check, this is, let me divide it like this. All right, this is your right side. So to the right, obviously is positive. We are talking about these forces to the right, which is a positive. So when you're referring right and left, you don't consider the sign, you just take your forces as they are. So it's 70 cos, because it's on this adjacent that you're talking about, that is to the right. It's on the horizontal line. So it's going to use a cos. So it's going to be 70 cos 45 degrees, 70 cos 45 degrees, plus we move on, we take another one, another from L. So it's L back to the horizontal. So this is the horizontal. There's an angle of 30 degrees. So it's going to be L cos 30 degrees. Cos 30 degrees. Okay, plus we still have another one from 50, still on the right side. So it's 50 back to the line. There's an angle of 60 degrees. So it's 50 cos 60 degrees. Remember, horizontal always uses cos. So now we are given the other side, which is on the left. So on the left, we only have this 80. Remember, we continue to do this. So it's going to be an 80. So like I said, when you are equating these, you do not consider the sign. The sign is not going to be considered. You consider the sign when you are calculating the horizontal components, like the sum of the horizontal component. You are combining. That is where you consider the sign. But in this case, you just take as they are. All right. So what am I going to do to calculate? Because as I can see, I'm having L here, which I can calculate from this part, because this is what I want to calculate. So can simplify this from 70 cos 45, 50 cos 60. You can choose to add this. You're going to be left with L cos 30 degrees. Okay, add these two. You're going to obtain 74,497 if you round off properly, which is equal to 80, like this. All right. So since we want to calculate L, you can transpose this so that it becomes a negative. So it's going to be L cos 30 degrees, which is equal to, you have to subtract 80 minus this value here. So 80 minus this value is going to give you 5,503. All right, so to find L, since this is multiplying, we can divide by cos 30. Just divide by cos 30 like this. You can find the value of L. So that is gonna cancel here. So from your calculator, this is 6,3. That is 6,354,317, something like that. So our L is going to be 6,354. You can round off to newtons here. So take note, guys, when you are calculating the magnitude, we are working with the magnitude here of the force. So if you are working with the magnitude of the force, you do not consider the negative of the force here. Just like this force is here, this 50, it is on the negative, but it's not written like minus 50. You are supposed to know, due to the direction where it is, it's a negative, but we need the magnitude. So the magnitude has nothing to do with the sign. So there's no need for you to write that negative. Okay, that's the same thing with L. You can see that our L on the diagram, this L here is supposed to be a negative because of the direction where it is. So we are not going to consider that negative. We are just going to take the magnitude of the force. That is why when I was equating this, I didn't even consider also the negative part. So that's what you're going to have there. All right, then we've got our L using the forces to the right and forces to the left. What can we do now to calculate M? We are going to move on to another concept of forces. Remember, upward forces are equal to the downward forces, the sum. So this is what we are going to take this time. We are going to take the upward forces being equal to the sum of the downward forces. So this time we are talking about up and down. So which means we are talking about the vertical component, because that's a vertical line. So those which are up are equal to those which are down. So which ones do we have which are referring as upward forces? Okay, the first one, M, is direct because we are talking about forces which are above this horizontal line. So which force are we talking about? We've got M here, which is above. So we're going to start with M. So that's M plus we still have another one which is up here from 70. This is the one that we're talking about. This is a positive horizontal, as we can see, and it's an opposite. So if it is opposite, you're going to use sine. Anything that is on the vertical, you use sine theta. Okay, so this is going to be 70 sine. All right, so that's 70 sine theta, which is sine 45 degrees, which is equal to, do we still have anything? We do not have. We are just left with these ones which are below this line. As you can see, these ones, they are below like this. So if they are below this, these are the ones which are down, F down. Okay, so that is what you're going to get from these ones. So you're going to have L back to the, which is L and 30 degrees. So it's L sine 30 degrees. Okay, we move on to 50 and 60 degrees. So it's 50 sine 60 degrees. So like I said, you don't consider the signs when you are working with equal forces. You just take your forces as they are. But we are given the value of L, guys. Remember that we obtained this L, it was 6,354. Here we have got the value of L here, 6,354. So we're going to use 6,354 in place of L because we already have this value here. So that is the idea there. All right, so what I want you to do is to combine these. You're going to be left with M plus 70 sine 45 degrees, which is equal to, I want you to combine this because you have got the value of L, which is 6,354. So 6,354 sine 30 plus 50 sine 60. You combine those two, you're going to obtain something like 46,478. All right. Now we want to calculate the value of M, so we can transpose this to the other side, which means we can subtract. So 46 minus 70 sine 45 degrees, this one that we just brought here, we are going to be left with a negative value there. It's going to give us minus 3,019. Okay, so don't be surprised about you having negative values. It's not even an effect. It's just a direction to show you that where that M was going, it was going to the negative side. But when you are writing the magnitude of M, the magnitude, we do not consider this sign. The sign is for the direction, but the magnitude is just 3.019 newtons. That is what you are referring as the magnitude. The negative is indicating, or it is representing the direction. If it was about the direction, therefore we are now stating the direction where this M is, which is to the west, because it's having a negative in the vertical, which means it's going to the south. Sorry, that is going to the south. If it was in the horizontal and it's a negative, that is where it's going to the west, because we've got west and it's negative and here it's positive. So the same, south going negative and north, it's positive. But here we are not given about the issue of the direction, so that's why we just need to write it as a positive like that. So that's what we had. And another question that we are given is to name two conditions for static equilibrium if the forces acting on the framework or object are in equilibrium. What do we have there? Okay, so what are the conditions? That is the question. All right, so these are the conditions that you're going to have for 3.3, guys. Conditions for static equilibrium: the sum of all the forces in any direction must be equal to 0, and the sum of all moments of the forces about any fulcrum must be equal to 0. So that's what you just need there. I think these conditions, guys, they are just direct and straightforward there. So that's what we had on 3.3, and we want to see the final part, which is on 3.4 there, where we are given Fig 4 below shows a structure. Determine the magnitude and nature. Take note, guys, it's not only about the magnitude but also the nature of the forces in members A, B, and BC. So we've got A, B, and BC. So if you are to take about a closer look of this question, you'll see that we have tried by all means to work with this type of a question, and it's one and the same working and that you do. Okay, so to calculate AB, let's just start with AB, where we've got upward force of 45 kilo that we are going to use, this one of 45 kilonewtons. So which means we shall end up with something like this. If you use this 45 kilo, it's going up, but there's an angle which is in between here, this one and this one. So we've got A, B, and C, and 60 degrees there. All right. So in this case, I'm just going to work with AB and 47,5. That's 47,5 kilonewton in this case. Okay, that's what I'm having. So just forget about this C. Don't mind about it for now. Work with AB because it's the one that is on the vertical part. We want to work with the vertical part. Remember, the vertical part is the one that gives us upward forces to be equal to the downward forces. Remember the concept. So in this case, this is one that is going up. As you can see, it's pointing up. So don't mind about the issue of the forces like being positive or negative. Just take as it is. So we've got 45, which is 47,5, is equal to. So for this one to be a vertical, because when you're talking about up, you're talking about a vertical. So this is what you want to calculate here, this side. So it's going to be AB sine, because it's a vertical. Anything in the vertical, guys, know that it's sine. So it's going to be AB sine 60 degrees. So to find AB, divide by 60 both sides. So our AB is going to be 47,5 over sine 60, which is one and the same thing. So from this part, you can actually calculate our AB, which in this case, using your calculator, just try to know you're going to obtain something like 54,84, and that's 8482 again. Yeah, something like that, which is 75. Yeah, so you can round off to 3 decimal places, which is going to give you 54,848, which is in kilonewton. As you can see, these are kilonewtons. So that's your AB. But it's not about just finding the magnitude, it's also about the nature. So which nature are we talking about here? So this is a strat. So remember AB, guys, it's a strat, okay? Then BC, for you to have your BC this time, remember the concept, we need to be FBC. So now we are going to work with forces to the right equal to forces to the left. So you're just going to take this as this. Don't mind that, just going to be like this, and this is your 60 here. That was our A, B, and this is our C. So F right should be equal to F left. All right. So on the right, what we have, this is where we've got our BC. So BC is equal to, on the left, if we are to bring this AB to be on the horizontal, which means it is going to use cos theta on the horizontal. This is already C on the horizontal, so there's no need for us to use, it's just going to be BC. But this AB now to the horizontal is going to use cos, so it's going to be AB cos 60 degrees. All right. So remember, we want to calculate BC. So BC is equal to AB. We obtained AB as 54,848. Remember the value that you obtained here of AB. So you're just going to multiply 54,848 cos 60 degrees. So that's what you're going to have from this value, which is going to be, if you multiply, you're going to obtain a direct decimal of 27,424, which is 424 in kilonewtons, because the others, they're in kilonewtons. So that's your BC, and you agree that's BC, guys, that's a tie. So that's how you actually answer this question. So it's not about determining the magnitude this time. This time we need the magnitude and also the nature of that force that you're given. So you just take a consideration of the force. So this is kilo, this is kilo, this is kilo. This one is just a matter of rewriting in it's supposed to be kilo, also kilonewton, like that. Okay, guys, so that's how you were supposed to obtain a total of 14 marks from this question paper that we had from April 2020 on forces. So that's it, guys, from Memo African Motives, working on engineering science and 3 question papers and revisions. Till we meet again.